Hello students, welcome back. Previously we went through the limit rules, but the limit rules are, what can I say, very important theoretically, but in practice nearly useless. So let's take the third approach. First, remember we went through a graphical approach. Second, limit rule approach. Now the third approach, computational approach. Okay, how do we handle limit computation? Well, let's take a practical step-by-step approach and do your computation. Step 1 usually is to plug in. If it works out, then it'll work out. Oh, okay, all right. The previous computation I did in limit rule computation, probably I made a sign mistake somewhere. You're supposed to get 8 over 2 equals to 4. Let's see, what's the limit rule solution? Okay, that's the limit rule solution. Let me expand the font so that you can see this. First, the division rule. Limit over limit. Quotient of limit is limit of the quotient. And then the addition rule. To be a little bit more precise, this should be plus, and then that should be negative 2. Okay. Limit of sum is sum of the limit. And then, as a matter of fact, even this solution skipped a step. The coefficient rule, 3x squared, and coefficient rule, 3x, okay, would have been better this way. And then negative 2 is out. All right, and then we use the multiplication rule. X. So finally, we can apply the trivial rule, plug in x equals to 1. So 3 times 1 times 1. And then 1 times 1, okay, 3 times 1, negative 2. So if you do your computation, 3 plus 5 is 8. 1 plus 3 minus 2 is 2. So 8 over 2 is 4. Previously, in the previous video, I made a sign mistake and got 8 over 0, but sorry, that was a mistake. This is the right computation. Anyway, nobody does a computation like this. It's stupid. Everybody will do it this way. Just plug it in. If it works, it works. Computational approach. So limit rule approach works, yes, and theoretically it is important, but in practice it's nearly useless. This is better, and this is more useful. Let's go back to the normal size. How about the next example? Plug in x equals to pi. Tangent of pi over 2 over pi squared plus 1, that's certainly undefined, because tangent of pi over 2 is undefined. Is there further remark? Oh yeah, okay. Depending upon whether I follow the graph from the left or from the right. Yeah. Pi over 2 minus pi over 2 plus, we may get positive infinity or negative infinity. Yes, we can decompose like that, but that's not what this problem asks. So just plug it in and then we get nothing, so undefined. So those are examples of trivial limits using the practical approach, the computational approach. Just plug it in. If it works, it works. Now, what if it doesn't work? Well, let's classify those into several categories. And the typically easy categories that you have to know is 0 over 0 type limits and infinity over infinity type limits. Some other types are there, but I don't think you have to worry too much of those yet. First, 0 over 0 type limit. Okay, here we go. If you plug in x equals to 2, what happens? Stop the playback and go ahead. Are you going to get 0 over 0? Well, yes you do. You will get 0 over 0. That computation is left to the students. So if you have a 0 over 0 limit, what do? There are a couple of ways, and the first method I'm going to tell you here is a factorization method. The second method will be discussed several weeks later, so that can wait. First, let's factor this. Factor the numerator, factor 2 out, and I have x squared minus 4. And then x squared minus 4 is actually x squared minus 2 squared, so you can factor it as x plus 2, x minus 2. All right? Let's write like this. So you can simplify just a little bit like this and then factor further. How about the denominator? Well, this is monic, so it's easy factorization. We're going to get x minus 1, x minus 2. Did I do this right? And then you can clearly see that the common factor here will divide each other out and disappear. And consequently, you're going to get this limit. And the latter limit is a trivial limit. It's not 0 over 0 type anymore. It's okay to plug in. If you do that, what do you get? 2 times 2 plus 2 is the numerator. And the denominator is 2 minus 1. And that's going to be what? 8? 4 times 2 is 8. Well, let's see. What did I do here in my answer key? Yeah, that's 8. That's the correct solution. Wrong solution? What do you mean by this? Wrong solution? How can it go wrong? Oh, I see. Okay, all right. Look at these. We got the same answer here and there. Please tell me why this is correct and why this is wrong. Here, we have limit expression, which is just highlighted in blue. Down here, no limit expression. The first equality is okay. I just factored. The second expression is not very good. This expression, this equality is not very good because I crossed these two out. So eventually I ended up with a different function. I mean, these two expressions here and there are almost the same, but not exactly the same. So this is a bit problematic. Now this one here, this is a big problem. This is wrong. Left-hand side is an x expression. We can take different x values, so that's a function. The right-hand side is a constant. The left-hand side and right-hand side of this red equality are not the same. So this one here in general, it's not the same. So even though you get a final answer correctly, this is not a good solution. If you do like this, of course, I'm not going to give you 0 credit, of course. I'll probably end up taking maybe 3 points out of total 10. And if I'm really good mood, maybe 2 points. No, 2 points is too generous. 3 points off, yeah, okay. If I'm bad mood, maybe 5 points off. The moral of the story, the problem is about limit computation, so keep the limit notation. If you keep the limit notation, then everything is okay. The limit notation disappears when you plug in. Even if you keep this limit until toward the end, it'll be still okay because the trivial limit rule applies. So if you have LIM, as I highlighted this, all the way, then good, that's correct. If you do without those, then be careful. This is not right. Now, what if you do not use equalities and, just separate these, whatever? Technically, there's no equality, so there's no wrong equality either, right? This is not really a good solution either, because this is a correct mathematical sentence that's written in correct mathematical grammar. It's a sentence with subjects, verbs, and objects and things like that. The verb of this object is the equality sign. A equals B. You see, equals, that part is the verb. Now here, we have no verb. This is not a sentence. This is grammatically wrong. You can still get an answer and communicate to a certain degree, but we just spoke without verb, just like I, Tajan, you, Jane, those kind of things. Well, to a certain degree, you can communicate each other, but that is far from sophisticated communication fit to the college level. So this kind of answer, of course, is worse. So if you write like this, probably 5 out of 10, if you're lucky. And worst case, 3 out of 10, just 3 points for the correct answer, and all these are considered as nothing. Well, okay, all right, that's a bit too bad. About 5 out of 10 sounds realistic. So, please practice writing as well, because after all, what is the key component that you have to learn from this course? If you classify, well, it is basically critical thinking, communication, and empirical and quantitative skills. Creative thinking, that goes to pretty much everything you learn in college level. Empirical and quantitative, come on, this is a math course. Everything is quantitative. Did I say qualitative? Sorry, quantitative. Empirical and quantitative. So everything is quantitative, so no problem there. What about the communication? Well, we do not write essays here. We do not follow the APA or whatever. No referencing and things like those. No abstract and introductions or things like that. You can start doing that in senior year. But, come on, me, Tajan, that should not be the aim of your college level communication. You have to do some level of mathematical communication, kind of like this. I ended up doing a bit of a digression here, thanks to this wrong solution I wrote, but I think it is time well spent. We're going to come back and discuss the other problems in a separate video. Okay. All right, see you soon.